So hello friend, this is Kausu Pathar again with a new video. Today we will come to the new topic or new chapter, that is differentiation or derivatives, 12th standard derivatives. So let's look at or revise some important formulas in the derivative before moving to the sums. So the first formula or the first rule is LH-Hospital rule. We also call it as the first principle method. So in this case we know that f dash of x represent the derivative of x. We know, always remember that anywhere you see in the engineering, in the BSc, anywhere in the further studies, when you go to universities or uh, colleges, so f dash of x always represents the derivative of a particular function. So here, to find the derivative of any function using the LH-Hospital rule or first principle, we use f dash of x equal to lim of h tends to 0 into f of x plus h minus f of x divided by h, where f of x is the function which we have to prove, which is a real value function, and h is the incremental, or we can say that h is the increment in this case. So we will prove in this in the next video. So let's come to the another derivative. As we know that the derivative of f of x raised to n is equal to n into f of x raised to n minus 1 into f dash of x. So remember, this is the most important derivative. This is the most important ever derivative in your this formula we will use in most of the cases. So remember this formula, that the derivative of any function raised to n is equal to n into that function raised to n minus 1 into an other derivative of that function, or the depth derivative of that function. So f dash of rep x here also represents the derivative of the function. This derivative can also be written in this formula as, if a derivative, let's say derivative of x raised to n, x raised to n equal to, I'm not putting the symbol of derivative, just for the sake of your convenience I am solving it, n into x raised to n minus 1. It will be n into x raised to n minus 1. So remember these things whenever this as f of x represents the x or the function of x or x. In this case I have replaced the f of x by x. So always remember that the derivative of any number, let's say find a derivative of x raised to 1. So it will be x n into n means 1, 1 multiplied by 1 in raised to 1, 1 multiplied by x raised to 1 minus 1, which will be equal to 1, uh, which will be equal to x raised to 0, which will be equal to 1. So remember one thing, that the derivative of x is always equal to 1. Derivative of x is always equal to 1. And one thing, derivative of any constant number, let's say we have to find the derivative of a. So the derivative of a is equal to 0. Derivative of any constant number is equal to 0. Derivative. Remember this thing, derivative of x is equal to 1 and derivative of any constant number is equal to 0. Let's come to the another property or another formula, derivative of square root of f of x. So very interesting example, derivative of square root of f of x is equal to 1 upon 2 square root of f of x into f dash of x. Let us consider as f of x equal to square root of f of x equal to x. Then the derivative of square root of f of x, which will be equal to replace the value of f of x by x. So derivative of x, I am not putting the derivative symbol just for the convenience, will be, so n in, it will be x raised to 1 by 2. So in this case the power is equal to 1 by 2, so the value of n is equal to 1 by 2. Again use this formula, n into x raised to n minus 1, or n into f of x raised to n minus 1 into f dash of x. So you will get equal to Now we will remove the derivative. So I'm not putting the symbol here. So it will be 1 divided by 2 into the x raised to 1 by 2, 1 divided by 2 minus 1 as per the formula, and I will close the bracket into f dash of x, and f dash of x represents the derivative of x. So derivative of x is equal to 1. So we will write 1 into 1, which is equal to 1 by 2, 1 divided by 2, multiply by, at the denominator put a divide operator, so it will be easy. 1 divided by 2 root of x, means here it is x raised to 1 by 2 minus 1, which will be x raised to minus 1 by 2. So another one step is here, so it will be x raised to minus 1 by 2. So 1 divided by 2 and multiply by x raised to minus 1 divided by 2. It will be minus 1 divided by 2. When it goes to the denominator, so it will become 1 by 2 x raised to 1 by 2. 1 by 2 x raised to 1 by 2. So here is the answer, and the value of 1 will be 1. This 1 will be multiplied, doesn't matter. So it will give 1 by 2 square root of x. So here it is, here the formula is proved that derivative of square root of f of x is equal to 1 by 2 square root of f of x into f dash of x. Remember, derivative of square root of f of x is equal to 1 by 2 square root of f of x into f dash of x. Another example. Now come here down, that derivative of another property, at the derivative of 1 upon f of x is equal to minus 1 upon f of x the whole square into f dash of x. So this is also very easy. So what is f of x? Let us consider f of x equal to x. So which is equal to f of x equal to x. So it will be 1 upon x. So derivative of 1 divided by x equal to, take the x in the numerator, so it will be x inverse. It will be x inverse as x raised to minus 1. So which is equal to x raised to minus 1. So put the formula, put this first formula. This first formula will be applicable to all the sums. All the means more number of sums. Almost all sums. Not more number, almost all sums. So put this formula as a value of n equal to minus 1. So put the value of n equal to minus 1 into x raised to minus 1 multiply by, again put a multiplication operator, and again the derivative of x is equal to 1 in this case. So which will be equal to minus 1 divided by x raised to 2 or x square. So the derivative of 1 upon x is equal to minus 1 upon x square in x square. So the derivative of 1 upon f of x is equal to minus 1 upon f of x the whole square into f dash of x. F dash of x represents the derivative of x function, means the depth function or the x function or the depth function, which we have to take the derivative afterwards. Taking derivative, and we are forming a loop of derivative, and we will go in the depth. So this minus 1 and minus 1 becomes minus 2. So it is in the numerator. If it is in the numerator, it is minus 2. So if it goes in the denominator, it will become plus. So remember one thing, that the derivative of 1 upon f of x is equal to minus 1 upon f of x the whole square into f dash of x. So similarly, we will find the derivative of sine, cos, tan, cosec, sec, cot. So here are the derivative of some trigonometric functions. So the derivative of sine x is equal to cos x, or sine of f of x is equal to cos of f of x into f dash of x. So also we will not we will prove it, but we will take an example of it. Suppose I told you to find the derivative of sine 2x. So the derivative of sine 2x, you will confuse. So you will put only cos 2x, but that's not the enough answer. Again we have to remove the derivative of this 2x. So we have to go into depth in order to remove the derivative. Go on inside the loop and loop and bring the derivative, go into depth and bring the derivative of the functions. So first of all we have to find the derivative of this larger function, then we have to find the derivative of the smaller function, then go on searching the functions. uh, and in this case you also have to bring the function into the simplest form for more complicated sums. So it will be cos 2x into the derivative of 2x. What will be the derivative of 2x? The derivative of 2x, the constant 2 will come outside and derivative of x equal to 1. So sorry, so which is equal to 2 cos 2x. So 2 cos of 2x will be the final answer. So in this case, derivative of sin x is equal to cos x, derivative of cos x is equal to minus sin x, derivative of tan x is equal to sec square x into f dash of x, derivative of cot of f of x is equal to minus cos x square f of x into f dash of x, derivative of sec of f of x is equal to sec of f of x into tan of f of x into f dash of x, whereas the derivative of cosec of f of x is equal to cosec of minus cosec of f of x into cot of f of x into f dash of x. So these 6 derivatives of the trigonometric functions you have to understand in order to solve the derivative functions. Now come to the logarithmic functions. Let's understand the derivative of logarithmic function. So we have the derivative of a raised to f of x. What is a raised to f of x? The derivative of a raised to f of x is equal to a raised to f of x log a into f dash of x. So in this case it is same as the limit we have studied in the last or the previous chapters, the limit. So the derivative of a raised to f of x is equal to a raised to f of x log of a into f dash of x. So similarly the derivative of e of f of x, e raised to f of x will be equal to e raised to f of x into f dash of x. Here we have not written log of e because log of e is always equal to 1, so it doesn't matter. So the next sum is important. So the next property is very important, as we have to find derivative of log of f of x. As log of f of x, derivative of log of f of x is equal to 1 divided by f of x into the derivative of f of x. Another, suppose I have given a function as 1 upon log of x square. So first of all it will be log of x square. So in order to simplify the function like log of x square, I will log of x square. In order to simplify such kind of functions, which will be equal to 1 divided by x square, but that's not the enough answer. The final answer will be 1 divided by x square into the derivative of x square, which is equal to 2x, means into the derivative of x square, which is equal to 2x. So I have to multiply the 2x with this function, and the final answer I will get is 2 divided by x, will be the final answer of the log of x square. So x will get cancelled in this case. So the final answer will be 2 upon x. So let's come to the final derivative of a derivative property of a log function. So derivative of log of f of x base to the a is equal to 1 upon f of x log a into f dash of x. F dash of x represents the derivative of the depth, or the we can say the loop derivative, loop we can say. So remember one thing, that dy by dx is the derivative, f dash of x is also the derivative. So the d by d of x of log of f of x base to the a is equal to 1 upon f of x log a f dash of x. So remember these things. So if you like my video, please share, subscribe and comment on my YouTube channel Making Maths Easy. So for more videos related to the mathematics, please subscribe my channel. Thank you for watching.